Okay, ladies and gentlemen, we have already added and subtracted angles, so now, not shockingly, we're going to multiply and divide them. Now, the good news for you is we're only going to multiply or divide them by 2. So let's take a look at a little of an example. Cosine of 15. Cosine of 15, you say, well, I can do that. That's 45 minus 30. That's like the last module. However, I could also say cosine of 30 divided by 2 would also make 15. So I'm going to use the properties right in here, double angle and half angle. These two sets of properties are going to be my buds for this particular module. Now we have power reducing. We'll come back to those a little bit later. But in this case, if I have cosine of theta over 2 equals plus or minus the square root of 1 plus cosine theta all over 2, I'm going to simply say, well, wait a minute, theta equals 30, because it's the thing I'm dividing by 2. So square root of 1 plus cosine 30 all over 2. Now, the cosine of 30 is very easy. Everybody knows the cosine of 30 is? That's right, it's square root of 3 over 2. So we say equals 1 plus the square root of 3 over 2 all over 2. Now, ladies and gentlemen, that is a fine way to leave it for now. At this point, you're really doing nothing more than simplifying, so leave it there. Now, as for the plus or minus sign, you'll notice there's a plus or minus up here. We need a rule for that. So, let's go grab a rule. The answer is right here. To determine which sign is appropriate when using a half-angle identity, check the quadrant in which theta over 2 lies, not the quadrant in which theta lies. Okay, so if we go back over here, our theta lies in the first quadrant. Our theta over 2 also lies in the first quadrant, so it really becomes a moot point. In both cases, whether it's 15 or whether it's 30, the cosine is going to be a positive sign. So we're going to put it here. But what you're looking for is you're looking for this. Where does this lie? So for example, if I had 105, cosine 105, which would be half of 210. 210 is something we know, 105 isn't, but 105 is in the second quadrant, so it would be a negative for its cosine value. So, you have that. It's not too shabby. You say, well, if I could do it this way, why would I do it this way? Well, again, I just gave you the 105 example, but additionally, what about 22.5? You say, I can't add or subtract anything that I know together to get 22.5. So I'm going to say it's sine of 45 over 2. Okay, so I need a property. If I have sine, a half-angle sine, it's going to be sine of theta over 2 equals the square root of 1 minus cosine theta all over 2. So you'll notice these two formulas are nearly the same except one is plus and one is minus. And again, in this case, you're going to end up with a plus or minus sign. Since both are in the first quadrant, we're going to just deal with the positive. So I'm going to say square root of 1 minus cosine 45 all over 2. So that is square root of 1 minus 1 over root 2 all over 2. Again, do you start to see why we're not rationalizing here? It would just be a big mess. Now, additionally, if I can cut things in half, I can also double things. So I can say sine of 60 is a sine of 2 times 30. 2 times 30. Now, these are somewhat less useful in this function because every angle I have, if I double it, I already have another angle that I know anyway. But when we start getting into the verify, simplify, and solve problems, we're going to need these formulas as well. So, sine of 2 theta is 2 sine theta cosine theta. So 2 sine 30 cosine 30. Okay, so with that, let me just double check it here. If we go to our double angles, there she is, right there, theta, theta. But I memorized that one because this, right here, this little property is the one you're going to run into probably second or third most out of all the properties you use, and you'll use it in calculus quite often. So, sine of 2 theta equals sine theta cosine theta. That one is definitely one worth putting in the memory banks. Now, sine of theta is going to be sine of 30, excuse me, is going to be 1/2. Cosine of 30 is going to be root 3 over 2 times the 2 that was out front. The answer is root 3 over 2. Now, by the way, if I take sine of 60, if I have 60, that's root 3, that's 1, that's 2. Yes, not shockingly, it is indeed root 3 over 2. So it does verify. Now again, that's only the basic usage. We can turn it around and go the other way. That becomes helpful as well. But really where we get into using these is in the simplify, verify, and another example I'm going to show you next. Now in a problem like this, if we take a problem similar to this guy right up here at the top, like number 1, we have find if cosine of theta equals 3 over 5 from 270 to 360. That means that I'm down in this quadrant right over here, and I know that the adjacent side is 3 and the hypotenuse is 5, and so I can find the missing side using Pythagorean theorem, or Pythagorean triples in this case. Now, they want me to find sine 2 theta, cosine 2 theta, and tan 2 theta. Well, I'm just going to do tan 2 theta because I already showed you sine 2 theta. And tan of 2 theta equals 2 tan theta over 1 minus tan squared theta. With that, I can easily, once I have a triangle, say, well, the tan of theta, because this is theta, that's what it's built off of. I don't know what 2 theta is, but I do know what 1 theta is. 2 times negative 4 over 3. 1 minus negative 4 over 3, the quantity squared. If I start simplifying just a little bit, negative 8/3 all over 1 minus 16/9. Again, this would be fine, or this would be fine, or if you choose to simplify. But you'll notice we simply have some fractions here that we need to deal with. 9 over 9. So I have negative 8/3 divided by negative 7/9. So I'm going to multiply by the reciprocal. And cancel, cancel, cancel. 3, negative 24. So I got 24 over 7. There you go. Okay, so the idea here is this is fine as long as you can put the property into use. Now, for cosine 2 theta, you have a small issue. Cosine 2 theta actually has 1, 2, 3 different formulas that can be used. One is similar to one we've already seen. So cosine 2 theta equals cosine squared theta minus sine squared theta. And so in this case, we would say cosine of theta was 3/5. Let's square that bad boy. Minus sine squared, that's going to be negative 4 over 3, and square that bad boy. Right up. Nope. No. Sine over 5, excuse me. And square that one. So in this case, go ahead and finish these out. This is going to be 9/25 minus 16/25. You come up with negative 7/25. Okay, so when they're simple fractions like this, that's fine. If they're stuck under a square root or they're double fractions with sums and differences, that's fine. You may leave them. Okay, so you could find this using any of these properties because, again, if I replace sine squared with 1 minus cosine squared, I can create this. Or vice versa, if I replace cosine squared with 1 minus sine squared, I can create this formula. So really, these three identities are the same. So we've used some half angles, we've used some double angles. Let's do one more example. Okay, here's some of those simplify, verify, or solve problems. In this case, we're going to do some solve problems. And I'm actually going to start right down here first because sine 2 theta is a little easier. There's only one formula for sine 2 theta, and you're going to see it over and over and over again. So I'm going to say 2 sine theta cosine theta equals cosine theta. At this point, we do need to remember that we cannot just divide by cosine theta because we might be eliminating a potential solution. So 2 sine theta cosine theta minus cosine theta equals 0. Factor out a cosine theta, leaves 2 sine theta minus 1 equals 0. Then I'm going to separate it out. Cosine theta equals 0 and 2 sine theta minus 1 equals 0. So where does cosine equal 0? If it's in 0 to 2 pi, it's going to happen at 90 and 270. Over here, we're going to have sine of theta equals 1/2. And sine of theta equals 1/2 at 30 and 150. There you go. So there are your potential answers. Now, let's go back up here. The reason I didn't do this one first is because you'll remember we have multiple cosine 2 theta solutions that we can use. Now, if I have a sine squared here, why don't I do something that changes everything to sine squared? 1 minus sine squared theta minus parenthesis 1 minus 2 sine squared theta equals 1/2. Now, at this point, everything's in terms of sine squared theta. All I really need to do is give away the negative. Boom, boom, boom. And at this point, this one and this one are going to cancel. And I have 2 sine squared and a negative 1 sine squared, so I end up with a sine squared theta equals 1/2. If I square root both sides, I have sine of theta equals plus or minus 1 over root 2. And so where are all the places that it equals plus or minus 1 over root 2? 1, negative 1, negative 1, 1, root 2, root 2, root 2, root 2. So I come up with, in 0 to 2 pi, I come up with 45, 135, 225, and 315. Okay, so a couple different ways to solve using double and half angle identities.